Hey everybody, this is Giovanni Santostasi. I am the scientific director, the director of the Scientific Bitcoin Institute. I am here with my colleague Stephen Perrenot. He's the vice director of the institute, and this is the show for whoever is joining for the first time. It's called the Physics of Bitcoin Show. We have doing this thing for quite a bit of time. This is our 45th episode. And the idea of the show is that we are trying to use not just analogies, because the analogies sometimes are interesting, but we are trying to go deeper. We are trying to use actually the tools that a physicist will use to study different kind of systems, and we apply them to Bitcoin. Sometimes we actually use data. We have both shown data that bring in, like, for example, the economy of cities. One time I was showing that Bitcoin scales very much as the economy of many cities around the world, for example. But it's usually focused on Bitcoin and different aspects of Bitcoin. And we are building this evidence with different degree of confidence that actually Bitcoin is a very interesting system. It's much more than an asset. It has all these interesting characteristics that are shared with what we call complex systems, and they are very prevalent in nature. But also in human activity. I mentioned cities. Cities is probably the best point of reference, but there are others. Today, for example, I was bringing up as a reference in a discussion that I will describe later with an economist, a macroeconomist, that doesn't like Bitcoin. And I was pointing out that actually there is literature showing that power laws are being used as a valuation framework to give value, or, to actually look at the value of companies like Google, Facebook, that are network like Bitcoin is. And actually they are proposing that is the right tool to understand how this company grow. In fact, the title itself of the article, this, by the way, is an article published in the journal Nature, that is actually one of the most prestigious scientific journals in the world. Like, usually if you have a paper in Nature, you kind of like you made it in the scientific world, and it's very selective in terms of what they choose to publish. And this article made it in Nature's journal. And the entire thesis is that these companies demonstrate power law properties. That is really interesting, and it's not in the valuation of a market cap, because the market cap is, like we know, we discussed it many times, is actually an exponential growth, mostly because the mechanism that work in the market are different than what works in other contexts. In this case, their valuation has to do with their sales, their ad sales. It is really one of the best way of giving value to this company. The market cap in the stock market is probably kind of an artifact, and this why it doesn't follow something more fundamental. But when you look at their actual sale, it is a power law like Bitcoin. So it's really cool because Bitcoin is actually valued in the market with a power law. So it's even more directly a power law than these systems are, so it's even more fundamental. But we will go in these details later. Okay, and so I also want to report I have been at the largest conference around Bitcoin, that is the one that has been held just in a few days ago in Las Vegas. It was very interesting, the very interesting encounters. One I mentioned, I will mention the other one. Hopefully I don't reveal too much, because it was kind of a private party, but I guess mentioning that I met an important Bitcoin personality is okay. And also, I will focus on the scientific discussion that we had, right? So I hope is okay with the people involved. But in general, it was really nice. I met a lot of Bitcoiners. That is actually really most interesting thing about going to these conferences is the social aspect. That is part of what we are saying gives value to Bitcoin. The fact that Bitcoin is a social network. I love what Stephen says. It is a meta network, right? It's a network of networks, and the social network is one component. And this is how you make the social network, going and participating to these conferences, even if sometimes it seems futile because it's very difficult to listen what people say, and most of the time the discussions are not really deep on the stage. But meeting people, it's invaluable. And at a certain point, I had the opportunity to meet these kind of important people in the network, and I will tell you more. There was also that I don't know if we have time this particular episode, but at a certain point, Stephen, we should discuss a little bit. I know that maybe your attitude is why we should even do that. Let's, this is not worth it. But there is basically, let me describe it in this way, and then maybe at the end of the episode we can say a couple of words, and if it is worthwhile, maybe we will have a deeper discussion about that. But basically, there are two young people, and I am the first one to be supportive. If for example, if these two young people contacted me or Steven, that we are relatively well-known personalities with physics background, right? Not because it's a question of authority, referring to authority or maybe gatekeeping. It's a question of, we are a network. There are people with certain competence. Why don't you go to these people with this competence, in particular if you're a young people? This is how I will have done. If I have some intuition or some interest and I think maybe I can contribute something valid, I will try to contact people with some knowledge, in particular if I don't have a mentor or maybe I don't have any competence in the field. Because from what I understand, and I'm pretty sure I didn't go deep in what is their background, also because it's not easy to find background on these two guys. They don't have physics degree. It's kind of obvious in how they discuss the subject. But so I will be very supportive of young people say, I had this big intuition about physics. I want to make a connection with Bitcoin. And they wrote like a 200 pages document. It seems quite interesting, and it's a big effort. But what is weird is that it got picked up by a couple of people, like, for example, Jeff Booth, that are looked at by the community in a very respectful way, because they wrote a book, they had some thesis about the relevance of Bitcoin, and there are some problems with even Jeff Booth assertions. I even wrote something in my book about that, because actually what he said, and whether maybe we can even discuss that, right? It's mostly because, and maybe I'm wrong, it's just that there is a big big component of a community that look up at certain individual, and it's great because if there is an individual that come up and they want to write books and they want to make arguments about the important Bitcoin, it's good. It creates a lot of interest. People can have discussions, but then some of these things became almost like dogma, and people are not questions on the idea level, right? So it doesn't matter if I think you're a great guy and you're contributing to the Bitcoin community. If your ideas, all the things you say are not correct, then, in particular, something that is not a question of philosophy that you can debate, it's a question of math. And math and data are not debatable, right? Maybe up to a point, because you can still debate the interpretation of the data. When what you're saying goes so against the data that Pauli, famous physicist, had a saying that this is not even wrong. He had this sentence that meant it's not even in the category of something being wrong, like maybe in your calculation, your procedure. It's just like it doesn't even fit, not in terms of curve fitting, but it's not the right approach at all. It doesn't. It's not even wrong. It's maybe you understand what is meant with that. And this is why I want to discuss it a little bit, because it has two levels of wrongness, not even wrongness. One is this attention that is getting, and in particular, direct or indirect support from important personalities in the Bitcoin world, and the other, the fact that their conclusion is that we should ignore quantum threats, but not at the level of what Stephen says, for example, that is, we need to understand the problem. This is how difficult it is. It's going to take all these years. It's not yet a problem because it will take much longer than most people say. And we have enough time because there are known solutions to the problem. It needs to be addressed, but it's not this imminent threat that some people that are spreading FUD intend to do. It's very different. In their cases, they come up with this completely crazy idea that because of the nature of a blockchain, that makes it quantum resistant per se. That is, like I say, not even wrong. So, and we can discuss why. And I don't know if this is the right episode, but at a certain point, maybe next episode we can do it. So that is one of the things that happened during the conference. They actually had a stage and we were discussing. But to be honest, it's a little bit upsetting because I have tried to contact the conference a few times. I have been invited to many other conferences. It will be nice, I think, for the community to hear more about the power law. I was there. I was in a booth stand with a company I'm working with, so I had the book. I talked with a lot of people. I sold more than 50 books at the conference. But by the way, I donated the proceeding of the conference to the Scientific Bitcoin Institute. So thank you for your support, guys. But it would be nice if, not from a ego point of view, but because of discussing the ideas and presenting people with the information. The information, of course, is there, but it would be also symbolic if we could have, at supposedly the biggest Bitcoin conference, a presentation. To be honest, I think it should be a keynote presentation, but it would be nice to have a presentation about one of the most important and relevant facts about Bitcoin, that is behaving as a complex system. But, they ignore that, and then they give stage to this pseudoscience that is crazy. I think it's a bad look for the conference and for the Bitcoin community, because a lot of people started to actually push back and say we are kind of new agey, quantum mechanical believers. That is not good. But anyway, so I think as kind of a house physicist for Bitcoin, in-house physicist for Bitcoin, we should maybe discuss it a little bit, at least from a pedagogical point of view, what these guys are saying and why it's wrong. So maybe we can do that in a particular episode if you are up to it, Stephen. I don't know what is your position about that. I think I know a little bit, but maybe.
Yeah, well, my general position is to not waste too much time on pseudoscience. I mean, when you use their Pauli quote that it's not even wrong, another way to say that is it's not even science. There's nothing they do that adheres to this scientific method, except, as you did point out, they do have some discussion about the thermodynamic nature of hashing and proof of work and so forth. And that's useful discussion. And, that can be supported. But when they start talking about the quantum nature of time, they just don't know what they're talking about.
Yeah.
And so, we could waste time refuting them, or we can proceed with our own research. And I think it's useful for us to talk in general about the issue of quantum computing and the actual threat that it does represent. It's a real threat. And I'm not sure they even know the difference between Grover's algorithm and Shor's algorithm.
Right.
It turns out that the nature of hashing is such that the Bitcoin blockchain is very, very resistant for many decades to Grover's algorithm, which would just be another way to hash. And it would just be as if, oh, we had ASICs before doing our hashing. Now we've got some quantum computers doing our hashing. It wouldn't fundamentally violate the structure of the network. So everything that matters for the next couple of decades is the issue about Shor's algorithm and breaking the keys. And, that is definitely worth following and tracking. And it's a real threat. It's not a threat to most addresses, but it is a threat when you move your coins. And
that has nothing to do with the blockchain itself.
It has nothing to do with the blockchain itself. It's the wallets, it's the keys.
Yeah. So how the blockchain operates is not even has anything to do with that particular attack approach. And the only reason I will want to, maybe at least from my side, use my academic freedom to cover topics that I think are relevant is mostly pedagogically, because maybe give us an opportunity to explain where it's interesting to study the blockchain and where is actually, that is part of our manifesto. We are saying over and over again that Bitcoin is an interesting physical system, that should be studied, should be understood. But going from that to make it something mystical, where it is now a new model of reality, it's like insane. It's like, no, that is actually the wrong direction. That makes us look bad, because somebody could say, oh, listen to this guy, what they are saying. It's like a kind of almost like, Deepak Chopra mentioning.
They're undermining the general concept of what the physics of the blockchain itself is. And so it'd be useful for us to talk about how the creation of the blockchain is a classical process. There's nothing that quantum in the creation of the blockchain. All the quantum nature is in the ASIC devices and in the the trapped charges on the nodes.
They don't percolate to the classical level, like nothing that happens at a quantum mechanical level percolates in classical physics, because it cancels out, right? There are all these effects that cancel out. And this is why you see the classical physical world. It's an interesting thing that the blockchain has, these timestamps. First of all, in general, the timestamps are on the order of 10 minutes. So if you wanted, let's say you wanted to use the blockchain as a point of reference.
The timestamp itself is 1 second resolution. It's Unix time.
Right.
There's nothing close to the Planck constant.
No. But they say, imagine you wanted to use the blocks, right? The blocks time when they are basically determined, right, and selected, and then use that as your absolute time frame, or whatever you want to call it, right? It's insane because it's 10 minutes. And if you wanted to measure anything that is less than 10 minutes, it will not work, right? So how do you address that, right? You don't. Or you could divide the time in between the block in equal amounts.
You can't.
But then you're back to...
It's a Poisson process.
Right. It doesn't make any sense, right? So, yes, there is some intuition there, and it's great with some two young people wanted to understand physics, so at least they went, probably they did some level of research, they did some reading, etc. But then they diffused this thing that should have been like, okay, stays there in a corner of the internet, and now is presented on a stage on the largest Bitcoin conference. It's really embarrassing. So that is something that I think we should, as a scientific Bitcoin Institute, you should have at least a minimum of a claim that, okay, this is not how you do Bitcoin physics. This is not. But we can do something maybe later in a more thoughtful way. But I did want to mention as an interesting event. But anyway, so let's go ahead with the show, and let's have your presentation, Stephen.
How's that?
Sounds good. Let me choose something with minimize or yeah. Okay, great.
Okay. This is number 45. I titled it Log Periodic Dominates versus the Fourier Cycle. So I'll show some evidence for that. But there's some other topics. But a lot of it is about log periodicity, and then that will include a comparison to the linear cycle. But for the log periodicity itself, we have FFTs. We have another thing called Lomscargo, which is a way of doing FFTs on data that's not uniformly spaced in log time, because most of the data we have is daily or weekly. So it's linearly spaced, not logarithmically spaced. And then wavelet transforms and, you know, the maps of that, how much energy there is at different frequencies. Well, and then we look at harmonics. So we have our fundamental and we have harmonics, and we have how much energy is in these different modes. And then how does that evolve with time? Does energy move between the fundamental and the harmonics? And also, do the phases drift? Because we do have to consider the phase as well as the frequency in these models. And then closing this portion, the main portion, I'll talk about the coupling between the power law, which is CSI, which is continuous scale invariance, and the discrete scale invariance that we see with the log periodicity. And then I've got a couple of slides on, given that we're, you know, have bounced from 61,000 to 82,000 since what, early February. How long's that? 3 months? How long is it going to take us, do we think, to get back to the power law on trend, which of course is an objective that's rising. We've got to catch up to something that's also moving upward at 3% a month. And then I have one slide commenting on master and why the power law is relevant to strategy of the company. Okay, so here we've basically taken the residuals. So the gray line are the residuals in log price terms. And you see the major peaks at 2011, 2013, 2017, the double peak in 2021. You see a mini peak in 2019. And then you see the more recent structure in 2024, 2025, when we had a peak, but we didn't have a bubble of the scale of other bubbles. We really only got a little bit modestly above the power law. You see the zero line. We only poked a little bit through the zero line up to about 0.1 in log price residual terms. And then, of course, we had that big downdraft in Q4 of last year. And then, you know, we seem to have found a bottom the past few months. So what are we showing here? The green and orange lines are log periodic fits, where we have either 2 modes or 3 modes. And 2 modes means the fundamental frequency, which I'm going to show you for log periodicity, and plus 1 harmonic, and it's the first harmonic. In other words, it's 2 times the fundamental frequency. And that's the orange line. And you see that we can get a better fit with 3 modes. In particular, we fit that whole 2017 to 2021 series of uplifts and big bubbles and smaller bubbles better than we do with the 2 mode, which tries to pull them together into one broad thing. But in general, the 2 mode fits pretty well. The 3 mode fits rather well. And you can see also that both the 2 mode and the 3 mode in the past year were kind of trending upwards. So they did not actually predict a break downwards with that one. And it's worth understanding that we're not trying to explain everything with log periodicity. We're trying to explain something around 50 to maybe at most 70% of the residual structure. And the rest would be external, exogenous, and influences from macro and everything else. And another one of those influences might be, have a linear cycle, because it might be tied to a business cycle or to the liquidity cycle globally, or to other macro influences. And then also there's the question of the halving, of course, which is 4 years. So that's the blue line. And I did a fit. I looked at different linear frequencies, linear timescales for those, and found that actually 3.5 years fits better than 4 years. So the best fit is the blue line. It's not great, but it's not terrible. I mean, it sort of fits 2011, and it sort of fits 2013, but it's not quite in phase with those two. It does fit 2017 and 2021. It fails to explain 2019, the mini bubble. Interestingly, it does pick up the behavior in 2024, 2025, and has kind of a downdraft in late 2025. But overall, it's not as good a fit, and I'll show you the statistics on that. So here are the statistics. So the first two lines in the table are the log periodic 3-mode and 2-mode, and you can see what the R-squareds are. It's 0.53 for the 3-mode, 0.48. So they're both pretty good. They're both explaining about half of what the residuals are doing. And you can see that the 3-mode is omega, which is the fundamental, and then 2 omega. And in this case, I use double that, the 4 omega for the third mode. With the linear, the best two were at 3.5 years and 3.7 years, and the R-squareds are only about 0.2 for both of those. But what's really telling are the AIC and BIC, which are the information criteria statistics. And here you want to have a negative number, or at least the lowest number when you compare models. And you can see that we get numbers like -200, -300, whereas they have positive numbers like 128, 145. That difference of 300 and 400 is extremely significant. If the difference is only 100, you say that, model A is heavily favored over model B. So it's very strong. If you look at the root mean square means and medians, they're sort of comparable. There's not much difference. They're all in that kind of a little bit below 0.2 or 0.2 level in the log price terms. Okay, and this is what the projection looks like. So on the chart, we've got just the power law trend fit, and then using those models, just a 2-year projection moving outward afterwards. And to see better, I've zoomed in. So if you look down in the inset, you'll see the zoom that goes from basically now, it shows you 2025 and early 2026, but it goes from now until April 2028. And the green line and the orange line are the projections for the log periodicity plus the power law. And the blue dashed line is the power law plus the linear cycle. So we'll be able to see which one of these performs better. Obviously, we're well below now. I think the last data point here is showing around 70,000, and now we're above 80,000. So we're up kind of one more tick mark right now. But we've got to get back to the power law. And so we'll see what kind of course we take over the next couple of years. I would argue that, we should get back up to the power law a little more quickly than you would see with this linear model, and that we would get some uplift as well from those log periodic components. If you look at the forecast table, by the beginning of next year, just power law only, you'd expect 161,000. And with the linear cycle, you'd be at 132,000, but with the 3-mode log periodicity, you could expect to be close to 200,000 by the beginning of next year. Okay, and then this is the, the science underneath it and the math underneath it. It's those same log time residuals that I showed you before, and we do a Fourier transform on them, and it's showing the power on a logarithmic scale on the y-axis. It's showing the frequency on a linear scale. Oh, sorry, it's showing the frequency actually on a log scale. Is that a log scale? 3, that is a log scale. Showing the frequency on a log scale on the x-axis. And the units there are cycles per log 10 decade. And so in those units, the fundamental frequency is 3.2. And you see the peak. It's quite strong. It's quite a bit stronger than the power at other places. And then the green vertical dashed line and the blue vertical dashed line and the purple one mark the second, third, fourth harmonic, when by second I mean twice the frequency and 3 times the frequency of the fundamental, or you could call it the first harmonic. It's the first overtone. The 3.21 in cycles per log 10 decade, using that little equation, exactly converts to the angular frequency that we use in our modeling on the prior charts. And that is 8.75. So you just multiply by 2 pi, you have to divide it by the natural log of 10 to get the scaling right. Okay, and then this is another way of analyzing, which is wavelet transform. It uses this same frequency in cycles per log 10 decade. And if you look at the upper one, you can see that the frequencies run from about 1 to a little above 10. That is a logarithmic scale there. It's a linear scale of calendar year on the x-axis, and there's a very clear fundamental a little above 3, around 3.21, where you see the yellow coloring and the green coloring, and that band stretches all the way across, and it's pretty flat. There's not much variation as that moves across. And then if you go up to the dashed lines up above, those are the overtones, the harmonics at 2, 3, and 4 times the fundamental. And they're getting closer because that's on a log scale. And you can see that there's power, particularly around the second harmonic, but up into the next one as well. And then the graph below is this same information, but on a different scaling for the color scale, and where we're looking really over several orders of magnitude for the power instead of linearly. And so there you're seeing, how much power is at the high end, and it really is spreading out to the second and third harmonics across pretty much the whole time frame. But you also see that there's shift, where eventually the fundamentals seems to be shifting up into the higher harmonics. And I'll show you some more detail on that. And again, the 3.21 corresponds to this 8.75 in angular frequency when you put it into the log periodic formula, which is a cosine of an expression which is the angular frequency times the log of time plus a phase. This is a wavelet analysis, and here the wavelet spectrum is showing again the same fundamental at 3.21 as a peak, and then the next peak is a little higher than 6.42, which would be the harmonic, and getting somewhere in between those two harmonics, the 6.42 and the 9.63. So in some of the modeling, I use a synthetic harmonic, which is actually takes a blend of those two. And then the large plot below is looking at the wavelet ridge. So it's basically asking that fundamental that I showed you, which was the band that stretches across and had that yellow and then green coloring. How flat is that? Is that really constant all the way across? And it turns out there's a little bit of structure in there and a little bit of modification. That it's kind of around this 8.75 center line, but it moves up and then later it moves down. And if it's increasing frequency, that's more often. If it's decreasing frequency, that's less often. And so that would say even in logarithmic timing, that it may be stretching out. And that angular frequency of 8.75 corresponds to a log periodic scaling parameter, which is basically your distances between peaks and troughs, of lambda of 2.05. So when you're right at that line, it's saying that these things are spaced double. If the interval between the first two is 2 years, then the next interval should be about 4 years. And then after that, about 8 years. And in fact, if omega is getting lower, lambda is getting higher because it's a wavelength, not a frequency. And so there may be some stretching out going on, or, that could happen with phase shift, right? Or it could happen with energy moving over into harmonics or subharmonics. Okay, and then this shows the energy fractions per mode with time. And I have 4 modes. Sorry, I have 5 modes shown here because I've got a subharmonic in blue, which is 1/2 of the fundamental. And then I've got the fundamental in orange, and then the harmonics, the higher harmonics in green and red and purple. And you can see most of the energies in the fundamental until we get to 2018, but then we have significant energy that we find in the harmonics at 2 omega and 3 omega. And the subharmonic is never that important. And the higher one at 4 times the fundamental has a little bit of importance later on in time. Then the brown coloring is everything else that's not explained by those. So these 5 modes are explaining 61% collectively on average. And then 39% is in the writhe, which is the exogenous activity. So for those of you that have seen my talk where, I guess it was our last one, where we talked about the DNA structure and the structure of magnetic field lines and the analogy with the sandworm, where we have the topology with twist and writhe. So twist is the log periodicity, the collective modes of that. And writhe is everything else, which is exogenous, not endogenous to the structure. Our argument is that the log periodicity, the discrete scale invariance, is intrinsic to Bitcoin structure and its geometry. This is another way of showing the same thing. The orange line is the fundamental. You can see it dominates, but then it falls off. The brown line is the writhe. It's the second most important thing. And then the next most important one is the 2 times fundamental harmonic, especially after 2018. And then even later, we get a little bit from the 3 times harmonic. The subharmonic is never very important. It's a very long and slow time scale. And this just compares the 2 times fundamental, the first overtone, with the fundamental, and asks which one has more energy. So if you're below the dash line, then there's more energy. More than half of the energy is in the fundamental. But if you're after 2018 or approaching 2018, you've got more energy actually in the 2 times fundamental harmonic. And then one can ask about phase drift. So here I've got 2 models, both with 3 modes. The blue line, I use fixed phase, and the orange line I allowed for phase drift. And you can see that the one with phase drift does do better, especially as we get into 2017, 2019 with the mini bubble, and 2021. The fixed phase is not catching the 2017 and 2021 bubbles very well. It's overestimating what would happen in 2019. What is interesting is that the fixed phase, has a more aggressive uplift currently. The one that allows for phase drift, the orange line, has also, though, turned up in the latter part of 2026 and is heading up. They're both below 0, so they're both looking to cross the center line, which is the line at which you're on the power law. So they are both suggestive of the fact that we would be below the power law, but they didn't fully explain the drawdown. Although the fixed phase went as far down as the drawdown did. It's just that it was too early in its timing. Okay, and then there's something that we call a hidden variable, which is the coupling of the behavior over time of the power law, which is the blue line, and this fundamental frequency, which is the orange line, and then something that we define as a coupling constant. And there's an equation that's in bold that defines that coupling constant, and it's equal to the power law exponent, which is, as you know, around 5.7, and times the log of lambda, which is the log periodicity parameter. But you can also write it as 2 pi times the power law exponent and divide it by the frequency, because there's an equivalence between the log of the log periodicity parameter lambda and 2 pi divided by the angular frequency. So all three of these have some kind of varying behavior, oscillatory behavior, or quasi-oscillatory behavior early on, but then they kind of lock in with time. And especially the power law exponent and the coupling constant, even more so. So the orange line, the angular frequency, looks kind of like the ridge I showed you. It's basically showing the same thing as we saw before. So it kind of heads up above 9 and then it drops down. Its average is around 8.75, but it's now a little bit above 8 now, 8.2, 8.3. The power law, shot up above 8 with the very earliest bubble structure, but it consolidated. And after 2016, it's always been below 6 and above 5.5. So it's locked in. And the standard error is very small. It's only slightly wider than the line here. So that's locked into 5.7 or 5.8, depending on which regression technique you use. And if you do it in gold, you'll get a slightly different number, but in dollars, 5.7. And then this coupling constant went through the same kind of process, and it locked in around 2016, and it's been close to 4 ever since. And right now it's about 4.29 is the mean. It's slightly above that mean, which is that dashed line. So we don't observe this directly, but we observe it indirectly by combining these two observables. The fundamental number that associates to the power law, the continuous scale invariance, and the fundamental number, which you can either use the omega or the lambda, either one suffices, is that. And that's the fundamental number for the discrete scale invariance of log periodicity. And so the idea is that you have something that's a deeper geometric structure, or even what's called in physics renormalizable group theory. Okay, so that's scale invariance coupled together, both continuously and then with discrete interruptions with the bubbles and the troughs. Now, the immediate question is, I thought it'd be interesting to find out, well, when are we going to get back to the power law trend? And so I looked at all the crossings, but I wanted to avoid zigzag. So I built in this little buffer or window that's plus or minus 12% around the center line, which is at 0 for the log 10 of the price residuals. And so that's, it's called hysteresis avoidance, but it's just avoiding zigzag. And so we're marking the lows and the crossings effectively by marking the highs and the lows after those. And you can see that it's kind of well behaved early on. Once you cross, you tend to stay cross for a while, and you don't get too much zigzagging around that buffer. You get a little bit, but as time goes on, you get more. You see a little more in 2019, but recently you've seen even more because you see a lot of dots, colored dots. So it's been it's been bouncing around in that zone or in that buffer. But we had a very severe drop, and it was a drop down to about minus 0.3, and that's a factor of 2 in price. So instead of being at the power law of, say, 125 or 120,000, late last year as a value, we dropped down to close to 60,000. That's a factor of 2. And then the question is, how do we get back? If you look at this, you kind of, and then ask chat to measure it. It kind of says 180 days on average to get back. And if our low was truly the first week of February at 61,000, then that would say roughly 6 months, August 2026. Now, I tried to see if there was any correlation of how long you get back with things like the age or the log age and so forth. I couldn't find anything. There were no correlations. The one strong correlation is just how big a drop did you take, or how big an uplift did you have? How extreme was the amplitude for your trough or your peak? And in that case, the Pearson R and the Spearman R are quite high. The probability of that being random is very low. So there's good correlation with the extreme amplitude. So then you can say, okay, what's the latest data point? 81,000. As of yesterday, the power law price would have you at 134,000. Your log 10 residual is minus 0.22, and that's minus 40% from where you'd expect to be on the power law. So how can we recover? So these charts are showing the recovery time from a top back to the fair value corridor, or from a low back to the fair value corridor. And the blues are after the bubbles from a top to the return. The oranges are our case where we're below and then we want to return. So if you look at these, they're kind of all over the map. There's nothing too clear, except usually you return in less than 1 year. But there's no sort of clear time dependence on this, as the statistics show. And then if you look on the right-hand chart, does a deeper, higher excursion imply longer recovery? Well, you can see some trend where the more extreme the residual was, not surprisingly, you just got more work to do to climb all the way back, right? So there is a trend there. I didn't really try to fit it because it's pretty noisy. The X that's gold color marks the 0.3, which is our minimum if we believe that the first week of February was our minimum at 61,000. The green X marks where we are now. And if you look at the past orange dots in that area, it would say, well, maybe you can get back within 100 days or so, probably less than 200 days. Let's say, 180 days is not unreasonable from the gold X, and 100 days or so from now, from the green X. But if you go from the low and say, what's the 25th percentile? It would have said March 1st. Well, that didn't happen. The median was 56 days. That was April 7th. That didn't happen. The mean, almost 140 days, is the end of June. So we have a shot at that. And then the 75th percentile of the distribution is at 200 days, and that's the end of August. So that's kind of consistent with the earlier argument. So one might reasonably say sometime between late June and late August, we could get back to the power law trend. And of course, it would be up, it's climbing at 3% a month. So if it's 130 something now, and it takes us another 4 months, well, it needs to be up in the 140s. So where do we cross it? Maybe, in the 140, 150,000 zone if something like this comes to pass. Okay. So a little patience to get back to the power law, but, it looks like we've got a bottom that's in. The behaviors, we have good behavior now with the market. Strategy got a lot of attention because they said, well, we might sell some Bitcoin. I think he'll do what is rational for the company, and I think he'll do what is rational for his long-term goal, which is to acquire as much Bitcoin as possible. So if sometimes he needs to sell a little bit to pay a dividend, or if the price gets really stretched upward, it's been proven by Sfornet and others that, smart money, the whales do offload a little bit when price is, well above 1 sigma and approaching 2 sigma or so higher than expected with the power law. And when we have these log periodic models, we get a little more insight as to when, that might make sense from both a timing perspective and how far above you climb. But I just wanted to say that I think that the power law is kind of critical to his whole strategy, because he's paying this dividend of, I think it's 11.5% right now on STRC. And, full disclosure, I own some of that. It's a nice income source. But the power laws could be critical for his whole business strategy to make it all work for the next couple of decades, strategically, but also psychologically for the market, and certainly financially, because it provides a framework in which long duration leverage against Bitcoin appears asymmetrically favorable. So it is not reckless to pay an 11% dividend if Bitcoin's going to climb as a power law, which means, right now, 38% per annum, roughly. And if you don't have the belief in a long-term scale invariant growth, then his whole structure becomes harder to justify. So the power law changes the geometry of risk. And Strategy's pioneering a whole new category, the idea of a public market Bitcoin reserve system where the products that you're selling are really duration and leverage and different levels of risk, but linked to Bitcoin one way or the other. So the system looks more like a sovereign wealth fund, or almost like a prime dealer. You have these prime dealers in the treasury market, and they're optimizing for inventory and duration, issuance, liquidity, and collateral. And I see Saylor and his team doing the same thing, but from the Bitcoin standpoint and Bitcoin perspective. It's not that he's being a Bitcoin central bank exactly, because he's not lending, but he's got Bitcoin as the reserve core, and he's leveraging the fiat market. So primary dealers are long fiat, and they try to stay delta neutral. They try to limit their exposure so that they can always make a little money off of the float. Whereas his strategy is to be clearly long Bitcoin and to be short fiat. And he's exploiting that old system in order to build into the new one. And with that, thank you very much, and I'll close out.
Great. Wonderful presentation, like always. A lot of interesting things. Yeah, I really care about this log periodic stuff, because if we can track it and demonstrate, the main problem we have so far is that we didn't have a lot of these oscillations. I think actually the higher frequencies help us with the stat. At a certain point, I think maybe we should look into that, right? Because we have more cycles, right, if we include the higher frequencies.
Right.
And so maybe there is a way of showing, if you break down the analysis using higher frequencies, actually there is a stronger case to be made, but something that I need to think about. But, we need to confirm it. I think it's less clear than the main power law, but if it turns out that it's a real phenomena, it will be really, really fascinating, because then you have this interplay between the two power laws, the one with the discrete value, so basically the complex exponent. Then you can unify them and say it's actually one single power law with complex exponent, right?
It's real, and it's real in FFTs. It's real in Lomscargo. It's real in wavelet analysis, and it's real because it exposes this coupling constant. And I'm going to show you next week the analysis that I've just done in the past.
Yeah, we need to publish a paper
in gold, and the gold fundamental goes all the way across.
Yeah,
Truly interesting.
I still want to hold up because I think it would be really amazing. I mean, it's like
Yeah.
it's so profound. I mean, my entire physics body is tingling right now. One time I saw, I don't remember who told me. I saw, I think it was Bohm, David Bohm. He said
Mhm.
that at a certain point when you started to study physics, at least in his case, and I completely agree, it becomes almost like a body extension. You start to feel it in your body, right? This was a sensation that I had with the power law. I felt it in my
Mhm.
body. I felt a shiver in my spine when the first time I saw it, because it's that clear. When you start to play with, basically, this is what the alchemists were looking for, right? This is what
Right.
the ancient mystics were looking for. This key to understand the universe, and people look at in everything else, religion, whatever. It's physics, because it's nature talking to us, right? We are asking the question, and nature is speaking back to us, and it does it in this language that is a language of mathematics. It's not a language that we chose because people were trying all kind of crazy things, like Kepler, for example, right? He was looking at geometric, like a platonic solid, all kind of enchantments or whatever. And then finally, he ended up among all the things, the math of logarithms, in fact, the math of power laws, because he discovered the laws of the planets through a power law. It is a power
Mhm.
law. Uh,
Yeah.
and, when you go in that direction, you start to see all these things. It becomes like almost like a physical sensation. You became one with your topic, and Bohm had this. When I heard that, I said, "Wow, this is so beautiful," and I want to embody physics myself. Right? In this case, I'm embodying a lot of mass. Right? I'm a big, massive planet or something. Uh, but aside the jokes, right? It's really cool, because if this thing turns out to be true, you have this interplay between the oscillations and the long-term
Right.
trajectory, and it's different, it's related, but also different from what Sornet is explaining, because the first time I started to think about this log periodicity, I noticed the difference, because with what Sornet sees are these faster and faster oscillations, right? That happen just before a bubble, and they are very local. This is global. It's not local. It's global.
Right.
It's a complementary Bitcoin, and it's the opposite. Instead of going faster, it's actually going slower. And so, if you could make the argument, if going faster reveals some kind of instability, going slower, it's exactly the opposite, reveals
Oh,
stability.
exactly. And there's amplitude decay,
Yeah,
so there's
exactly.
stability
So the
there.
two together, these
Yeah.
oscillations becoming slower in time in a very predictable fashion, and the amplitude becoming smaller. It's exactly showing that basically we are converging to the main power law, that is a long-term trajectory, and that is a sign of stability. And one could make a scientific argument of that. And it strengthens this idea that it's a self-sustaining system, because otherwise you will not explain this inner oscillation. And I really like this idea, and I love that graph that you had of the different energy components, where you also included interference from the outside. And in the future we can break it down. We can show maybe this component is due to the PMI, this component is due to the liquidity, because I explained this before. There are some analysts that don't follow our physics approach, that tend to be in two camps. There is the camp that say, "Oh, it's all Fourier cycle," and then there is the other camp that say, "No, there is not a Fourier cycle, and it's all external," right? Because the Fourier cycle is more internal. People are pointing to the halving; it doesn't have anything to do with the halving, or indirectly to do with the halving. And then there is these external cycles, and these two camps are almost like opposite. And instead, what we are showing is saying, well, look, there is an internal cycle. It's kind of related to the Fourier, because the Fourier is kind of a subharmonic, or it is there, but in a more sophisticated manner. It's not exactly Fourier's. It's a 4 years initially, and then it actually started with 2, when he went to 4, then it's going to 8. It's getting stretched, right? And but then there is a component from outside that is interfering or interplaying, let's say, interacting with these inner cycles, and that is really the physics way of looking at oscillations in general. When you study oscillation in a system, you look both at the inner resonances and outside influence. And it's an entire very fascinating topic, synchronization. So people wrote entire book, and we should start to study it in that way. And you're creating the foundation for that. So it's amazing. All this is very beautiful and interesting, and I don't know if people still appreciate it, because it goes like this, right? Like we say, a small percentage of the world understand Bitcoin, then a small percentage understand the power law, the continuous power law, and a small percentage of these understand the log periodic power law, right? It is even more sophisticated phenomenon, but we are doing this also because I think one day Bitcoin will be studied in schools, in university. This is part of what we do with the Scientific Bitcoin Institute. And so it goes beyond the urgency of, predicting what Bitcoin is going to do next. It's really establishing a science of Bitcoin, because Bitcoin is really, and on this, I am exactly together with these young people that I was mentioning before. Bitcoin is worthwhile to be mentioned as a very interesting physical system. It's a classical system, but it's a very fascinating one, and so it's worthwhile to be studied in all this sophistication and complexity, and we can learn a lot of things, in general, about human behavior, financial systems, how humans themselves are physics. That is actually something that many scientists have tried to show, including Jeffrey West, right? That I go, because we are, right? Life is made of atoms and molecules, so life is also physics. And living organisms working together is biology, and biology is also physics, right? And the economy is an expression of biology, because we are biological beings and we are physics beings, and there is no difference, right? Physics can study both the subatomics, and it can study human beings and human behavior. We are still physical systems, so very complicated ones, but we are physical systems. So it's really interesting and beautiful. And all the things that you say about Saylors, it's strange because, well, okay, I'm going to make a big reveal. The other person that I met at this meeting, it was kind of a VIP meeting. Again, hopefully I don't reveal anything that I should not reveal, but you can imagine who goes to these VIP meetings. So Arduino was there, for example. He's the CEO of Tether, and it was a very special encounter for me because he is Italian, and he's actually from my city. In fact, my city just honored him. They had a big event where they gave him honorary PhD. He studied in this very interesting institute that actually, on a certain point, I want to contact, because they study complex systems themselves. And you will appreciate also because this angle, Stephen, because me and you are both fans of Asimov, right? And Arduino mentions psychohistory all the time. And when I saw that, I immediately, kind of smiled, because it's very typical of Italian, let's say, nerds or people that are interested in science, because we are very fascinated by science fiction in a way that is not common in the US, weirdly enough, because Asimov is actually an American author. And we kind of revere these people, like, for example, Clark or Asimov. And I remember my childhood where I read almost every day science fiction. When I had to take a train to go to school, and the ride was about 30-40 minutes, and we'll spend it reading sometimes physics book, other time science fiction. And Asimov was one of them, and the Foundation was a classic. And many people, and some people mentioned a few times when they saw the power law, oh, this reminds me psychohistory, because basically you're trying to predict over the long term human behavior, right? You don't predict the single actions of humans, but you're predicting the collective action, at least in this very narrow particular field. And yeah, so I talked with him briefly, seemed very excited, very interested. He got the power law, he was aware of the power law, and I had a copy with me of a book, and he wanted that I was signing it for him, and I mentioned the power law is at least one component of psychohistory, is the closest thing that we have to psychohistory in the signing of the book, and I gave it to him. And so it was a very interesting encounter. Hopefully I will meet him again, in some event in the future, and it would be nice if he get involved with the Institute, because some of the things that they are doing, this long-term vision of what decentralization can do for humanity, is very much online with the vision of a Scientific Bitcoin Institute. And then I had so I was very happy about that. And then in the same event, there was a Saylor, and I introduced myself. He also was aware of a power law. He told me something like, you did very well. Kind of acknowledging, that it has an impact in the Bitcoin world. And then I say, well, what do you think about it? Give me exactly this word, give me your honest view. And he started to say, well, I think the idea, okay, let me tell you what he said, and I'm trying to interpret it. He said, well, Bitcoin is an exponential phenomena. So I think he wanted to say it's a non-linear phenomena, right? So exponential is used often for this, like it's something that grows fast. So power laws kind of in that category, right? I imagine that he wanted kind of say like that, right? You're seeing this behavior because basically it's the same thing than an exponential. And I tried to tell him, well, no, because yes, it's a non-linear phenomena, but power law is a very different beast in terms of consequences, in terms of his behavior, in terms of all the things, right? I mean, for example, and the problem was this. It took me so by surprise, and it should not have, because we kind of saw what is called Bitcoin 2025. What is called is model that we actually discussed on a point, Stephen. What is the name of that model?
I think it was in 2024, wasn't it?
Bitcoin 2024, right? This is how we called it.
Yeah.
And in that approach, you had actually three different models, right? And they were all kind of exponentials, like with changing rate of growth. And one was bullish, one was bearish, and then there was like the middle one that almost tracked the power law, almost exactly. And I don't know if you're using directly the power law as a way of creating the middle ground, or you kind of guess some numbers or whatever. But I should not have been surprised by this response, but I got surprised. And so I was not able to tell him all the other stuff, like, for example, mentioning Jeffrey West's lecture, where he makes a huge, big difference between power laws. Like, he says very clearly, he studied thousands of corporations, and corporations, they don't last, they die. Most corporations die within 5 years. Some of them last, but no more than 100 years. And he says there are no companies beside the Vatican, that is a joke, that last more than 150 years. In fact, none. There are a few companies that have changed name, they reorganize, so they kind of have the same name, but it basically are different companies. But almost no companies survive more than 150 years. And so, the idea is that they grow so fast, and they grow in this very unsustainable way, that is the way of the power of the exponentials. and then they die. And it's not what you want for Bitcoin. You want the other type of growth that Jeffrey West mentioned, that are power law, that slow down, and that is actually a feature, not a bug. They slow down on purpose to adapt, because then when you look at them in the right angle, in the right space, that is the log space, we started to discuss these more frequently, saying, there are these affine space where things became simple. Like, for example, the orbit of the planets. But people struggle with this description of the orbit of the planets for centuries, because when we looked from the wrong point of observation, that is sitting on the Earth, they look very complicated. They do these weird things that call epicycles, and they started to add components to it, right? They add cycles on top of cycles, basically almost like an analog Fourier transform, right? They added signs on top of signs on top of signs to describe this complicated motion, when it could have been much simpler by looking at using the right frame of reference, that is sitting at the center of mass, that is basically the center of the sun, because the sun is so massive that roughly it's the center of the sun. And then everything became simple. Same thing with the power law. It's a beautiful, beautiful analogy, because it's not just an analogy, it's true mathematics. If you go in the log space, then the power law becomes a straight line. And what does it mean? It means there is a proportionality between the scales. And that is what makes Bitcoin so unique, because it means, look, it's doing the same thing. It's a stable system. It's very different from an exponential. That there is no such a space where you can say the log of a price, but it's not really a space, because you have to do something weird to one axis versus the other one, right? It's not symmetric. And so the exponentials are associated with things that decay, or things that are not good, like cancer, for example. And Bitcoin is the opposite. It's this very systematic growth that is auto-regulating, is slowing down, because as it becomes bigger, the agents and the forces involved are much larger, so they slow down, like the heartbeat of an elephant. It slows down because an elephant with a very fast heartbeat will die very soon, right? It needs to take a different type of pace, and this is expressed by the scaling laws. Like, one can write an entire book on this topic. In fact, I did, right? I wrote an entire book on the physics of Bitcoin, describing the relevance of all these implications about Bitcoin being a power law versus an exponential. And I didn't have a chance to talk about all that, because the next thing he said, when I pointed out, I said, well, we know it's not an exponential, because if it was a simple exponential, it would look like a straight line in a log linear chart, and he was aware of it. And so he quickly responded, well, it's an exponential, something like that. It was really weird. He said, us that think it is an exponential know that is an exponential with a changing rate of growth. First of all, that is the antithesis of what an exponential is, because why will you say that? It's almost like I'm telling you this is a straight line, and you're telling me no, it's not a straight line, is the square root of a square. Why will you make it so complicated? Why you're adding that level of complication when it's a straight line? The square root of a square is a straight line. You're telling me that there is the fundamental characteristic of an exponential, fact is almost a definition, is that its rate of change is constant. That is the definition of an exponential. It's not that you cannot have an exponential mathematics. You can create any function you want, right? You can take the exponential of a square that is the cube of whatever. You can make a so complicated formula that involves an exponential, but it's not really what an exponential is. The essence of an exponential, it is a process that has a precise doubling time, right? And if you change that, then you don't have an exponential. You could have an exponential of a function, that is what it was proposing. And then the question is, what is this function, right? And so I wrote an entire article that actually was very, very well received. I had hundreds of likes, where I say, okay, let's play Michael Saylor's game. We say, the price is equal the exponential of some function, ft. And now we need to find what this function is. Okay, we are kind of going along the idea that Saylor proposed, that it's an exponential of some function of time, right? Let's find out what is that function. The beauty is that, you see, this is not philosophy, it's math. And with math, there is no my opinion, Saylor's opinion. There is truth. We ask nature, we ask in this case Bitcoin, what Bitcoin says about these hypotheses. So what do you do with something like that, that is price equal exponential of a function? You take the log of both sides, and now you look at the log of a price, and the exponential cancel, and you're left with the function. So we study what this log of a price is. We are not ready what it is, because we know what it is. It's a power law, but we play, right? We play this thing.
I don't know if you can see this, but I wrote a Substack article published on September 5th, 2024. Okay. So if people look at that, I don't know that this graph is coming across. What you will see is that, first of all, he had 4 parameters. He had to have a starting growth rate, and then he had a decrement in the growth rate, and a couple of other parameters. But if you take what he projects, then you take it out to 2045, which was his end date. First of all, the difference between his bull and bear case was a factor of 15. Yeah. So not very useful to be well over, 1 order of magnitude. But if you backward project, it doesn't match the historical data at all.
It doesn't. But
and so it's arbitrary numbers in a spreadsheet is what it is.
Yeah. And my approach was slightly different, where I say, okay, now let's look carefully this log of price that we know it's with familiar. In fact, you can show it. It's with familiar curve that everybody sees when you're looking at the log of price, because it's the best way to look at Bitcoin beside the log, because it it shows the changes from few cents all the way to 100,000, and then it doesn't look like a straight line. It looks like a curve, right? And then the question is, okay, let's try in mathematics, in statistics, we have a way of testing different models. You propose different models, you run the statistic on this model, and I had in my article 5 or 6 models. You can even have an AI training it and say, hey, running it until you find the correct model. By the way, I did something else in the past where there is actually this group of people that wrote some kind of a function that has different parameters that you can tune. And if you tune it in a way, you get an exponential. If you tune it in another way, you get a power law. I did that, right? And the result was it is a power law. So people are not aware of all the work that we did. In this, by the way, that entire paper, is called Beyond Sigmoids, because what we wanted to show that if you take data from many different networks, social networks, they don't follow the S-curve. It's basically a double exponential. It's an exponential going up and then an exponential going down, because basically it's the integral of a Gaussian. And the S-curve that many people mention. And they wanted to show you don't get S-curve for social networks. You get a power law. And they did it by using this function that actually can be tuned. And once you get the different value of a parameter, you can tell what it selects by introducing data. I did all that work. It's a beautiful power law. The data shows it. But I did it another way that is more intuitive, maybe for people, where I tested these different models. And the winning model, there were 2 models. One was the power law, and the other one was a stretch exponential. But then when you actually look at the correct value for this stretch potential, collapse to the power law. So the power law won, and everything else was garbage. And basically, I'm sorry, Saylor, your model is wrong. It's wrong, right? You're talking, people know you for that meme that, by the way, it was not talking about modeling Bitcoin. It was modeling microeconomics. But many people, there was a time when people will throw you in the face all the model will be destroyed. I don't even know what they are trying to say, because if we don't have, like Stephen pointed out, if we don't have a nice predictive model of a future of Bitcoin. A lot of what Saylor is doing is nonsense, in terms of his strategy and so on, because, or at least he loses a lot of value because, well, okay, why you're doing this? How do you know that Bitcoin is going somewhere, right? It becomes just fate. It becomes a bet. While if you have something that is stable and you can prove it is stable and has lasted for 17 years, and you can make the argument that it will continue because it went through 8 order of magnitude, and we are talking about maybe 2 more order of magnitude until we reach 10 million, then, it's a very, very powerful argument. This is why it's a missed opportunity, because the math of the power law is much, much better if you understand it as an orange peeling argument, but also something to present to institutions. And that is also the other thing that I didn't have a chance to discuss with him, because I wanted to tell him, and maybe, there'll be another opportunity, where whenever I had a chance to actually talk to professionals, right? Whenever I had a chance to talk to different people in the field of finance and so on, I'm trying to find a way of making myself bigger because I am the one speaking, but it's okay. Okay. I had the opportunity to present the power law, and in fact, I'm going back to Europe soon to do that again, to different conferences and so on. Whenever I was in front of a room of not the general public, but actually bankers, economists, financial people, and they saw the data, they were kind of shocked, because they do understand things are square, like R square. They understand, they see that straight line. They know, they look at data long enough that the majority of people, there are exceptions, people that resist because some personal reasons or some mental block, but a neutral person in the professional field of economics or finance, when he looks at the power law graph, they get curious. They really get curious. And I got a lot of people coming to me after this presentation say, this, I want to know more because this is extraordinary. I never saw anything like that in finance, and I want to understand more. So I think Saylor, and he will take, I don't know what stops him, if it is a pride thing, or if it is, I don't know, maybe a question of liability, because if he supports one particular model instead of a spread of model that basically it's like a big net, it's a net that can catch any fish,
I don't think that's it. I don't think that's it.
What do you think it is?
He could take power law model and put a spread around it. I mean, that would be a reasonable thing to do, to project, out to the financial world. I mean, he's already projected a model to the financial world.
Right.
But it's a model
and it's a bad model
because it does not explain history.
Yeah.
So
no, it doesn't.
Why project a model if it's a bad model and if it's not a useful model? I think the problem really is, he's an engineer. It's an engineering mindset, and that's different. He's an engineering guy, very good, who learned finance, and he knows a lot, and he's a great spokesman, so he has all those things going for him. But he hasn't asked this question that physicists like to ask, which is why. Why is it doing what it's doing?
Right.
And the reason why it's doing what it's doing is the same reason, with this Danish econometrician, they don't ask why. The why is because it's a network. And everything in the fiat world is not the kind of network that Bitcoin is. Bitcoin is a self-defining, self-creating, self-managing, self-organizing, self-optimizing social network of security. So Bitcoin does all those things. In the fiat world, you have to build your vaults later. You have to build your payment networks later, right? All those things are external add-ons, and that's why they're allopoietic. Bitcoin is autopoietic, self-creating, self-defining, self-maintaining. Yes, it requires energy input, It requires computers to be supplied, but it provides incentives to human beings to make them go do that. Bitcoin makes human beings supply hash rate by its Nash equilibrium game theory incentives, right?
Yes.
And that is a social network of security first and value that emerges later. Whereas the fiat world, the coin and the bills are created with the security of laws and military and police. But all of the structures for vault and payments, those get added on later. They're not intrinsic to that structure. Right. All that structure is allopoietic.
Yeah. Yeah, and we know all these, etc. That is true. I taught a lot of engineers. When I was a professor, I was a professor in college for almost 9 years. And I was interacting with a lot of them. And some of the best engineers were basically like physicists. They had a drive to ask why and understand the profound questions. And many of them wanted just to do things, and some of them were good in doing things, but they didn't go beyond that. It was just a way of, math and physics was just a way of interacting with the world and making things work, but they didn't ask the deep questions, And it's a question of character. It's a question of maybe background or drive or whatever. And it's a pity, because I think if he will embrace it, he will be able to explain it in a way that maybe me and Steve are not, because he has also a good sense of marketing and how to reach large populations. He's very good in making memorable memes, and so it will be really powerful. Maybe I should make I should create a AI version of Saylor with that is converted to the power law and see what he will come up with. It will be interesting to do. With disclaimers, right? This is not a real Saylor. There will be an interesting thing to try. What Saylor will say if he got the light. If he finally got he understood the significance of the power law. But maybe it takes time, and we will see. We are all in the same boat. I do admire Saylor. I didn't have a chance to tell him that too. I think he's part. Strangely enough, is part of a power law story, and the power law actually is essential to what he does, like Stephen say, and he will help the long-term success of his strategy, right? His strategy. And one of the interesting things, this is something that I had of an intuition when Stephen put it in words. Once you have a company like Strategy that actually does a good treasury policy, and some company try and then they fail because they do other stupid things, they don't manage it correctly, and I think Saylor so far has done this correctly. You go from being one of these corporate entities that follow an exponential to actually follow the power law, because after all, there is a strong coupling, even if it is not always there is a strong coupling between the valuation of MicroStrategy and Bitcoin. At a certain point, actually, there was a power law between the two. I didn't check it recently, but
it still is. I checked it in the last few weeks.
Yeah, it's still there. Yeah. Actually, there is a power law between MicroStrategy and Bitcoin. So it's a power law of a power law. Yeah. And that means that this company became immortal, right? Because this is what Jeffrey West says. That
just show him its stock price. That's all you have to do. Just show him its stock price.
He did what the companies don't do, that is to become immortal, and it's such incredible, relevant thing that, again, if he understood it and absorbed it and he started to make it his own, it could really be a punchline in many of his interviews, right? He will say, there is this physicist, Jeffrey West. He will point it in the right direction. Say, he points out how most companies die. MicroStrategy is becoming immortal, right? So it doesn't mince words. It can be very evocative in his words. So these will not be things that will not fit his way of describing Bitcoin, because he said very big things about Bitcoin. These will be backed by the math. And but it's a mix opportunity. Um, we added again an educational post where I explain why he's wrong, and how the power law wins in the end. Not because it's me against Saylor, it's because of the truth. Bitcoin is the ultimate truth, and we should all bow to Bitcoin and learn from Bitcoin. Because it's our point of reference, it's our object of study, and so we have to pay respect. And whatever Bitcoin does, it doesn't. It's not an exponential, and it's not an exponential with the changing rate. It's a power law. Anyway, so this was an interesting encounter. Then I think we don't have time. Maybe we can do it another time. This encounter with the economist and what he says. Again, we could take it as a pedagogical discussion, of how he's wrong and he's using the wrong math to describe Bitcoin. That will make a more structured presentation next episode. I will show this paper from Nature that shows, actually we show all the graphs. I didn't have time because it just happened today. I will make a more structured presentation. I will show what he said. It came up with some, basically was saying, with Bitcoin needs to respect this math, that is the math of the dividends. No, because it's not a stock with a dividend. Why you force Bitcoin in a square hole when it has a very different type of shape?
Yeah, Taylor made that. Nicholas Taylor made that argument a few years ago with some very fancy math, but it's just dividend math.
Yeah.
And he said, since there's no dividend, there's a magic absorbing barrier. It's going to go to zero and get stuck there.
Yeah.
And, I responded to that and was able to get him to block me. So
he blocked you, actually.
Oh, yeah, that was one point. Yeah.
He didn't block me because I was trying. I like him, and I tried to be diplomatic. I showed him even the power law, and his response was, "It's actually a bad thing that is a power law," because I think he was thinking I was mentioning the power law of a distribution of. So basically, thought, well, it's concentrated in few hands, etc. He thought that I was. He didn't even see what I was showing him. He just saw power law and immediately associated with the distribution of wealth. That it does follow, but actually, even that is an interesting study because it's becoming, strangely enough, more distributed, in particular now with the large agents, because the large agents are large agents, but they represent the public, because even MicroStrategy, when they buy Bitcoin, they don't buy for themselves, they're buying for the investors. And so it's a way of redistributing actually the economical impact of Bitcoin to the population. So it's becoming actually more distributed, not less. But it confused. He was not looking at the graph that I was showing it. It was the price, the addresses, etc. And I didn't want to get blocked. And if somebody doesn't want to listen, they are not going to listen. That is the point. They have to come to that conclusion by themselves with time. And I think if I am in a room with him, I don't know if it's going to have the same, because I thought the same thing. One day, if I was in the room with Saylor, I will be able to bring him to these conclusions. But the resistance was so much that I thought, I'm not going anywhere. If I start to say a bunch of things, he will dismiss them anyway, because that is his mental model, and it's very difficult to break through, So I think that if I was in the same room with Taleb, probably I will get the same result, So what we need to do is, publish papers, get our Scientific Bitcoin Institute going, having more scholars coming together, and then maybe one day, once we establish a science of Bitcoin and we have courses and we have more paper. Actually, you know that, right? There is another paper. I don't know if I show you. I will send you a link from these Portuguese professors that wrote a paper where they quote actually our paper that is not even published yet. And they mention, so it's another group of scholars that are actually trying to get published, talking about the power law in Bitcoin. And their paper is about how, if you look at short-term prediction, the autocorrelation is dominant. that is kind of the trivial answer of, if you want to do a predictive model of almost anything that relates to stock, to financial stuff, is the price today is the price tomorrow. Many eyes, that is one of the problems in training LLMs to data. They give you that as the answer because you didn't train it good enough or whatever. They give you this trivial answer that the price today is the price tomorrow. And when you look at it, it's like basically the same. If you do a model of it, right, it looks like the price was shifted by 1 day. That is the prediction. That is silly. But it's a decent prediction. And they show that prediction actually is the best prediction within short terms. And that short terms means 4 or 5 months. I want to kind of reproduce the result, see, because it's an interesting result. But then after it's a very beautiful graph. We have this graph where we show the dominance of the different model. One is just autocorrelation, and then the power law starts to be super dominant after 5 or 6 months. So if you're looking at trying to project the price, it is what we are always saying, that it's a long-term trajectory over period that are longer than 5 or 6 months. The power law is real and dominant. And this is an independent study by these people that are actually have professorships in a real university. So the thing that we wanted to do with the Scientific Bitcoin Institute is happening. More and more scholars studying the power law like a real phenomena in Bitcoin. And we will have more papers on that. So it's really cool. This is it, I think.
Yeah, no, that's completely consistent with the slide I just showed, which is, it takes about 6 months to get back to the power law, right?
Yep.
And so within half a year, certainly from a year later, they say it's the power law, and less than half a year, they say whatever the price is now is the best predictor. And then there's a transition, as you go from 6 to 12 months.
Okay, great. Perfect. Okay, so let me see if there is any comment or questions worthwhile to discuss. What do you think about this? It's very
well. This is kind of Jason Lowery's software thing, right?
Yeah.
So he's saying Bitcoin is, and I don't know whether you've read Lowery's thesis. I recommend that you do if you haven't, Josh. But his thesis that he wrote a few years ago for his master's degree at MIT, as a military officer, is that Bitcoin is another form of power projection. It's certainly a form of security. And I've just discussed it's a secure network even before it produces value. And that's kind of his point, that it's not just a monetary network, it's a network of security, and it can be used for power protection. And he basically says, which I believe as well in his thesis, that nukes are, obsolete, right? It's kind of difficult to use nukes at this point. There's too much opprobrium, and also, you use it and you can't constrain where the radioactivity goes. It's going to hit your friends as well.
Yeah.
But he argues that it can replace forms of kinetic warfare.
Mm-hmm.
And
it's interesting.
Have a battle over acquiring hash rate and acquiring.
Yeah. Of course, he's a military guy. I like the idea that Bitcoin actually can contribute to peace, but this could be another form of deterrent, and it's not. Unfortunately, having nuclear bombs is what prevented large-scale wars. It did work in that way. We do have wars, but we are all local, and the number of people that die in these wars is nothing in comparison with how many people died in the past. But maybe Bitcoin eventually could become a form of deterrent that is similar, but it's not. It doesn't kill people, at least not directly. And I think the same thing happened with finance, where many people have this very dark vision of what is going to happen in the future. There is some kind of collapse, etc. And it could be that Bitcoin, by absorbing a large component of the monetary wealth of the world, is avoiding that collapse. It's becoming kind of an escape valve, So actually something that it should be explored. Maybe it's an interesting angle to understand that it's a stabilizing force, Um, the best revolutions are the peaceful revolutions. My son is from Estonia. They got independent from Soviet Union by holding their hands across the entire country. That was one of the things that they did to actually express their sovereignty. To rebel in a certain sense. And it was a very peaceful revolution. They just held hands across the entire country, and they were singing. Of course, it's a small country. It will have been difficult to do it in a large country, but it's wonderful when you can do something like that, and it's revolutionary, and nobody dies. And I think that is one of the powerful thing about Bitcoin. That is winning. I always say this thing is like a Zen warrior that wins without even fighting. He's there. There is this famous Miyamoto Musashi that I think they put it in Karate Kid movie, but it's actually a real event, supposedly, where there was this famous samurai, and he was in some hotel, some kind of tavern or whatever, and he was eating his rice, and these challengers, because it was almost like the Old West, right? There was a famous samurai, and you will go there and challenge him, because if you killed him, then you will be the big next thing, right? You will get fame and whatever. You could be killed, but it was maybe some kind of a risk that you could take. These guys were three of them, and Miyamoto Musashi was old, so they thought that their odds were in their favor, and so they started to insult him and do all kind of things to provoke him to fight. And he took his chopstick and he caught a fly in mid-flight. And when they saw that kind of skill, they gave up, because they thought, okay, this guy is still amazing. We will all die if we try to challenge him. And he did that, not to kill them. He was able to avoid the fight. So Bitcoin is kind of like that, right? He can win even without fighting. Over time, you surrender to Bitcoin, right? It's assimilation is futile, right? With Bitcoin. So yeah, I think this is it, and it's a story of a power law. Over time, it's going to absorb the entire monetary system, and it's going to do it in a very precise manner. And yeah, few people understand it, few people appreciate, but this number of people is becoming bigger with time, and also we get the right allies, that are people with the right skills, like academia people, serious investor, like banks and corporations that are becoming more and more curious about this phenomenon. So yeah, we are going in the right direction. All right, and there is something about I don't know. I hope that you put the right number. I thank you to let us know, but I'm trying to keep track. So we have so many episodes. I will check, and correct. All right, guys. I think this is it. We went for almost 2 hours. Hopefully, we learned something in this episode. You wanted the math, we gave you the math. In fact, we give you the math every single episode, right? So I joke that the title of this episode was "Give Me the Math." We give you the math every single time. All right, guys. Thank you so much. We will see you next week.
Thank you, everyone.